Thank you for being here. And good afternoon, Laracon EU. It's been a really good day and a half so far. I've really enjoyed it, both as an attendee and now I'm here as a speaker. It's a great honor. So first of all, I just want to say a huge thank you to Sean and the organizers for putting on this conference and for inviting me to speak and share my thoughts on a topic that I'm really, really passionate about, which is testing. Specifically, 12 tried and tested top tips for testing. Quite a tongue twister. So I remember my first Laracon. It was 2015, so 2 years ago. Is this anyone's first Laracon? Just by show of hands. Wow, the majority of you, great. So, I mean, Laracon EU 2015 was a real turning point for me personally. It was my first Laracon. And actually my first big technical conference. Before that, I'd gone to smaller meetups, smaller conferences, and so on. But this was my first experience going to such a big event. Before then, to be honest, I didn't really know that this sort of event existed. So to go from that experience where I attended and was able to watch a number of really inspiring talks, one which stuck out in particular was one by Matt Stauffer on, I think the subject was empathy gives you superpowers. Not a technical talk, and at the time I had slightly mixed feelings about it, but looking back on it, it was such a great topic, and one that really inspired me, not only to become a better developer, to contribute more to open source, but also to get my feet wet and get up on stage and present my thoughts with the community. So thank you for being here today and for attending my session. If you can learn just one new top tip for testing, I'll be able to leave this theater a very, very happy man. So firstly, just a little bit about me. My name's Amo. I'm from London. I'm head of development for an energy research consultancy called Energy Aspects. I tweet occasionally at Amo_Chohan. Can you believe someone took Amo Chohan? I tweet predominantly about testing and PHP, and I'm a TDD evangelist. Now, just a small kind of precursive warning to this. These are 12 top tips that have worked for me and partly my team. So what I'm going to say is highly opinionated, or slightly opinionated, but not that opinionated. For anyone that watches Laracasts, you'll know exactly what I mean by this. OK, so let's get stuck into my first top tip, live templates. You may wonder, what does live templates have to do with testing? So for those of you that are unfamiliar, live templates is a feature within PHP Storm. I think they're called snippets in Sublime, which allows you to effectively paste in reusable snippets of code into your source. And I use these extensively. The way that I use live templates is I get them to actually write some of my tests for me, some of the repetitive tasks that I know that I need to write time and time again. Rather than me doing that by hand each time, I use live snippets to do probably 80 or 90% of the legwork, if not all of it, for me wherever possible. So as we can see here, we can just type test, which is what I'm using in my example, and it's going to stub out this live template test bootstrapper. And it doesn't do anything fancy, but it saves me a couple of lines, well, one line of code and 3 comments. So I write the word test, hit tab, and it's going to stub out the method name with a placeholder that I can type, hit tab. It'll then go to the next placeholder, which is my given statement, complete that sentence, hit tab again, and that's going to go to my when, do the same, and it's going to go to then. So pretty cool just to get you up and running without having to type things that we can really automate. So how do we set these up? It's really straightforward. So I'll show you just a walkthrough of 2 different ways we can do this. And then I'll show you a couple of examples of how I'm leveraging this system to help me write my tests for me. So go into Preferences in PHP Storm. In the left-hand side, just search for Live Templates. PHP Storm's a fantastic IDE. If you're using something like Atom or Sublime, I strongly urge you to, whilst they're great products, to also check out PHP Storm to see how some of the tools that it affords you can be used to speed up your workflows. So search for live templates. We just add a new abbreviation, so we can see here that I'm using, apologies, it's slightly small. We're using an abbreviation called test. So this is the keyword that's going to trigger my live template. And then I'm just going to add the code that I want it to stub out. So here it's nothing too fancy. We've got a test annotation, public function. You could remove the public if you buy into the visual det paradigm. It underscore and then a variable name. Now live templates uses $variable to signal a variable that you can use. So here I'm using the name of the test as my first variable, given when and then. They're not doing anything yet, but it's a good starting point. Another way we can do it is if we've already got a piece of code that we're using, this basic test setup, we can select it all, do a global search for live templates, which is triple shift on your keyboard. Select Save as Live Template. Again, specify the abbreviation that you'd like to use. So here we're just going to call this setup test. We've got the code already in the selection. So now we can delete that code, type the abbreviation that we've just assigned, which was setup test, hit tab, and it's going to insert that code for us. Again, it's not doing anything too complex right now, but you can see how when you're writing tests for business-specific or domain-specific functionality, I'm sure that you're often writing the same sort of factories or instantiating the same sorts of objects within your setup that you can just put into a live template and make it into a reusable snippet. So a couple of examples. Test I or test D, depending on your pronunciation, is one that I use every single day, multiple times a day. It's really, really simple. Type the word test I, hit tab, and I get a test immediately stubbed out for me that tests the instantiation of a brand new class. This is kind of TDD 101. Before I write any code itself, I should be writing my tests. And this allows me to get into that mindset very easily. Now, granted, it's not doing too much. It's just testing that I can instantiate a class instance. But assuming that the user object that I've used in the example here accepts a number of arguments in the constructor, again, I can add all of these manually, but most of the work has been done for me. And more importantly than the test itself is the value that it adds. It's a great reminder that I know that I need to continue adding tests. So when I extend the behavior in the user class, let's say if I add a activate method or whatever it may be, the friction that would be required to go from not having a test to, first of all, setting up a test class, testing ultimately the instantiation of the class, and then adding the test method for this new piece of behavior, well, I can bypass all of that just by using my live template. My test class is already there. I know the class is going to work, and it's done all of that work for me without me having to spend any time at all. Another example, and a slightly more complex one, is the test has many live templates. So I'm just typing the word test has many, and you can see this is a much more meaty test. It's got a much greater amount of setup, and it's got more complex assertions that are being added to the test. All it's doing is we're testing a has many relationship, so a user can have many comments. Now, you may argue, do we really even need to test this relationship? Isn't Eloquent testing that for us? And I'd say yes and no. I don't care about the way that Eloquent works or my database abstraction layer works, but what's really important to me is the behavior that a user must have many comments. And I can get this for free, so you guys can argue until the cows come home as to whether there is any value of having an Eloquent relationship test, but I've been able to gain that test just by writing one word. Perfect. So tip number 2. A dedicated test button. Now, tests are fantastic. I love tests. But to yield the benefit of our tests, we need to be able to run them, and run them often. It's great having them, but if the last time you ran your tests was 6 months ago, I've got news for you. They probably don't work anymore. So we need to be on top of our test suite. And this is where continuous integration servers come in, and they do a really great job of making sure that we're pushing only passing code to production. But we should be doing this locally as well. However, again, at the moment, our workflow is we alt-tab to the terminal, PHP unit, add our filters, and it can be a little bit laborious. So by show of hands, who here uses an external keyboard? OK, probably 30, 40% of you. How many of you, again, by show of hands, uses, along the top row, the F15 key? Just what I thought. So why don't we use these keys that are utterly redundant, or in my experience, I don't think I've used them once. Why don't we put them to some good use? Why don't we map that key to run our tests for us? So this is exactly what I've done. So here I've assigned the F13 key to run my tests for me. And that can either run a single test method, my full test class, or it can run my test suite, my full test suite, depending on the context within which I'm pressing that button. But as long as I've got my IDE open, I can press this button, and my tests are going to execute for me and give me immediate feedback on what the status or the health of my project is. Great. And I get to press a button that I haven't pressed before, which is great. In addition to having this dedicated button, again, it goes back to what I was saying previously, that tests are fantastic as long as we remember to execute them. But by having a dedicated button, and whether you've added your own little highlighting or you've added a sticker or whatever it may be, it's a constant visual reminder that we need to be running our tests. We've not only facilitated the ease of running those tests, but we're reminding ourselves subconsciously every time we're at our workstation. So how can we set up this test button? Again, I'm going to give all of my examples in PHP Storm, but I believe most of this can also be accomplished in things like Sublime. So again, go to Preferences. On the left-hand side, the second option is Key Map. Search for Run Context Configuration, as you can see here. And the example has F16 applied as a shortcut. PHP Storm is great. It will tell you when you've got a duplicate shortcut, i.e. if I've already got a different shortcut using F16, PHP Storm will remind me and say, hey, by the way, you're already using F16 to do this particular task. So we don't need to worry about that. So here I've used F16 for my example. So next, when we hit F16, PHP Storm is going to complain that it doesn't really know what to do because it doesn't understand the concept of PHP or how to execute our code. So we just click Fix to tell PHP Storm that we're going to add an interpreter. And personally, I'm using Homestead, as I'm sure many of you are. You can set up things like Docker, or if you've got PHP installed locally, all of that's supported out of the box. So I'm going to click on the Edit button and set up a connection. Here I've just used SSH rather than the dedicated Vagrant option, just to show that there are multiple ways of doing this. So I've provided the host as localhost. I've provided the username as Vagrant to connect to my box, and my SSH key, and in this case I'm using a passphrase, which I just wanted to use to connect. Great, so we've got a connection to Vagrant set up now, and we're almost on our way to running our tests through our IDE. But before we can do that, we need to tell PHP Storm how we can map our local project to the underlying virtual machine that's going to be executing our code. So again, apologies for the size here, but we can see that I'm mapping my local project, which resides in users Amo Chohan, codes Laracon EU 2017, to the Vagrant equivalent of where those files are going to be stored. Now, finally, we can hit our F15 or 16 or whatever our shortcut button is, and our terminal will automatically pop up within our IDE, execute our tests, and we get immediate feedback on a single button click. Great. So we're already now writing our tests, or we're using our IDE to write some of those for us, and now we're able to execute those very quickly. OK. So I was hoping to be able to hand out some of these stickers for you. I've produced a little batch. Unfortunately, the printer wasn't able to get them to me on time. I do apologize for that. But if you follow me on Twitter, slight marketing tactic here, at Amo_Chohan, I promise there's no cat memes or anything. It is purely TDD and PHP-related tweets. Send me a DM, and I'll very happily post one out to you free of charge. Tip number 3. Hit the database. So you may remember I said that this is going to be a slightly opinionated talk. And this is one of the topics that tends to be quite divisive. Many believe that you should not touch your database at all in a testing scenario. Certain people think you should be having an in-memory database, something like SQLite. I say forget all that. If you disagree, you can argue with me on Twitter later. But let me try and convince you. So hitting the database, fine. It's a little bit slower. I get that. It doesn't matter. A lot of the time, we're running our tests in the background anyway. So time we have almost an infinite amount of. OK, so we can't use that as a reason for not hitting the database. It's one extra thing to manage. Well, I would argue that to have a healthy local development environment, we should be staying on top of our versions of any dependencies and what have you anyway. So we can't really use that as an excuse. But the main reason for me is that I get the confidence to know that my applications are going to behave and execute in exactly the same way on production as they are locally. What I mean by that is, if I know that I'm using Postgres on production, why am I testing using SQLite locally? Or vice versa. In addition to that, it's just really difficult to test certain types of driver-specific queries using in-memory SQLite or using mocks. And a few examples of these that I've encountered are things like regular expressions. I can do those with certain engines, not with others. Insert on duplicate key update. Slightly wordy, let me explain to you what that does. When I perform an insert, I can add an extra statement to the end of my query to say, hey, I want to insert this record, but if you've already got the record, just do an update instead of any attributes that have changed. I use this fairly often because we're dealing with large volumes of data at my work. So this is a really useful statement to be able to execute, but I just can't test it with SQLite. Now, I can spend a couple of days on trying to get it to work, but what's the value to the business for me to do that? Ultimately, I can get running by hitting a MySQL database immediately, and I can move on to the next feature. Another example is generate series, which is a fantastic Postgres-specific statement, which, again, I just can't do if I'm using in-memory SQLite databases. OK, so on to my next tip, which is to write tests as features, not as technical jargon. Now, this is still specific to PHP unit, but what I'm going to show you is how I use PHP unit in a more BDD oriented fashion, rather than more of the unit testing style. So I'm sure that you've seen code like this in the past. So we've got a product controller test. Let's just assume that it's an e-commerce sort of environment. We've got a product controller that we need to test, and a method or a test method called test controller index methods. I'm sure you can agree that it's not very clear, without the descriptions that I've added in there, what exactly the intent of the developer is. We know that we're testing the index method of our controller, but how do we know that our test is testing the right thing? How do we know that it's a complete test? How do we know that all of the features that this method actually encapsulates are covered? And with a description like this, it's not only vague, but it's just really difficult to know where to stop. So to me, this is a bad test. Even if it's mocking properly and doing all of the right things, just the name of it strikes me as really odd. It doesn't describe the intent, and it is a very much PHP unit kind of unit testing old school style of nomenclature. So what I prefer to do is to be really, really verbose. And I've had test methods which are sort of almost 2 or 3 sentences long, because it's doing one very, very specific thing. But to me, this is immediately obvious that, OK, my index method actually needs to return to me a paginated list of the latest products that are in stock. OK. I mean, you may argue that this could be broken down into 3 different tests, but ultimately, I'm sure we can all agree that this is much more, it's much clearer than what we had previously, which was test controller index methods. So it's more of an acceptance style of test, and it's one that we can use as documentation, not just for developers on our teams, but also for stakeholders, non-technical stakeholders. It's great to be able to have a discussion within your team using language like this, domain-specific or behavior-related language, and a non-technical stakeholder is able to walk by and immediately understand the context of what you're discussing and ultimately be able to contribute to that. So tip number 5, marking tests as incomplete. So before I go any further, tip 4 and 5, the reason I'm describing these is because of the next tip. So these are quite important to take as almost a pairing. So marking tests as incomplete. By default, or depending on your configuration, you can write out your tests within PHP Unit, and even if they've got no content within them, when you run PHP Unit, your tests will be marked as passing. So be careful about how you configure your PHP Unit .xml file, firstly. But what I like to do is, when starting on a new project or a new feature or a specific unit of work, I like to list all of the features as independent tests. So going back to the product controller, I've listed out 4 specific tests. It displays the latest in-stock products. It paginates the products. The number of results can be controlled. A user can filter by price. So again, if we'd have gone back to the previous slide that I'd have shown, the equivalent of this is still test controller index method. So again, we've made real progress just by breaking those out using human-readable language to make our intentions much clearer. But I've gone a step further here. I've added the mark test incomplete method within each of the tests. And this is built into PHP Unit. Ultimately, what this allows me to do is to flesh out what I want this product to look like in a complete way. So I could write one test, bring it to market, make it passing, at the expense of potentially forgetting about the other 3 tests. By the time I've done one, I may forget that they need to be paginated. I may forget that they need to be, the number of results needs to be controlled, and so on. But just by writing them down almost on paper, that's now permanently part of my test documentation. It also allows me to elicit more requirements, or alternatively remove things that are not required. Additionally, I can prioritize. I know exactly where I need to begin because I've identified things like dependencies. Like, it holds true that I need to be able to control the pagination of results before I can allow a user to limit how many items are returned. So what happens when we run these tests? So by default, if I do PHP Unit or hit my keyboard shortcut, as I like to do, I can see that I'm not seeing that my tests are passing, which could occur depending on my configuration. PHP Unit is explicitly telling me that I've got 4 tests and they're all incomplete. Now, let's assume that I've spent a bit of time and I've got 2 of the tests or 2 of the features now working. When I hit PHP Unit again, it's going to tell me that 2 of the tests are passing, but I've still got 2 that are incomplete. So I get kind of that real-time feedback loop of how much work is completed and how much is remaining. So tip 6 goes really well with writing out tests as features, not technical jargon, and marking tests as incomplete. Test docs is one of my favorite options within PHP Unit. If you run PHP Unit with this option, what you get is a great little output, which is great for the way that we communicate with stakeholders. Try and cast your mind back to the last time either your team lead, or if you're working at an agency or a freelancer, your client asked you, hey, Amo, how's the project coming along? When can I expect it to be done? And it kind of puts you in a difficult position because you've been doing some great work. You've been making some real progress, but it can be quite difficult to quantify, well, I've done 20%, 30%, 50%. Test docs solves this problem immediately. By running your tests with this option, you get outputs in this format. It will convert your tests to proper sentence case, replace the underscores with spaces, and you get more of this sort of BDD kind of output. In addition to that, it adds these checkboxes. So you could print this out, give it to your stakeholder, and say, this is what I've done. This is what's remaining. Stakeholders love this because they can see exactly what's remaining and what's been done. That's also sometimes more important than what's remaining, because they can see that real progress, not just through the demonstrations, but holistically, they can see the health of their products. Going one step further, what I like to do is use test.docs HTML. Now, this is built on top of test.docs, but it adds an additional layer of printing the output. So this accepts a file name, which I'm calling progress.html. And what it's going to do, as I'm sure you can guess, is it's going to create a HTML file with exactly the same output. This is really empowering for you as a developer to be able to communicate in real time what your status is to your clients, to your team leads, to the rest of your to the rest of your team that you work in. You could email this out at the end of each sprint, at the end of each week or day, or whatever unit of work you use to track your progress, and set up a report that goes out in an automated fashion. And again, we've only got one product controller here, but this could be hundreds of features, it could be hundreds of classes. So you may want to decide how you filter this and determine what sort of output you want to generate. OK, so tip number 7, running tests on file change. Now, if you're not a fan of the dedicated hardware button using F15, there is an alternative. And this tip is made possible by some amazing work done by the guys at Sparsi. Hopefully, I'm not butchering the pronunciation of that. Thank you. Freak and his team have put out a package very recently, which some of you may not be aware of yet. So I thought this is a great opportunity to share that with you. It's called PHP Unit Watcher. And it does exactly that. No longer do you need to manually run your tests. No longer do you even need to run to touch your keyboard. Simply pull in this package using Composer. So it's a global requirement. And by default, it's going to watch, on execution, your source, tests, and your app directories. All of this is configurable. But it's going to watch those and execute those tests in real time. You can add filters to it. It's got a ton of configuration parameters. And overall, it's a really great package. Allow me to demonstrate that, but just before doing that, again, thanks to Freak and to his team for putting this package out. I'm sure that many of you use the numerous Sparsi packages, so I just want to take the opportunity to say thank you to you guys for all your hard work. So how does this work? OK, so we're going to start up PHP Unit Watcher. And again, by default, it's going to monitor our app, source, and test directories. And at the moment, it's fine. It's complaining that we don't actually have any tests, but that's fine. So let's write our first test. So we're going to just make a very trivial example of a greeting class. So using my test I sort of shortcut, I'm going to first make sure that I can instantiate my class, which doesn't exist yet. So this is really a 101 in how to use TDD. So we've got no code, but I want to make sure that I can instantiate this class. And as soon as I hit save, PHP Watcher tells me that this class doesn't exist. Great. Thank you, PHP Unit, for telling me what to do next. I can now create this class. I'm just going to call this greeting in the app namespace. We'll close that down. And again, if I hit save, this is still going to fail because PHP Unit hasn't, my test class hasn't imported that class. So let's go ahead and do that. Again, hitting save, it's going to trigger that test watcher, and it's now passing. So let's now implement our feature. So we want to print out a greeting. Again, a very trivial example, but it really illustrates the point here. So we've got our test class, our test method rather, it prints a greeting. We're going to new up an instance of our greeting class. And we're just going to assert that the output of our new method we're going to create is the same as hello Laracon. So again, nothing earth-shattering here, all really simple stuff, basic assertion being made. But on hitting save, it's actually pointed out that we've got a syntax error. So we add the semicolon, and it's complaining now that we don't have a greeting methods. Great. So again, TDD at its purest. It's telling us what our next step is. So we go into our greeting class. We add our greeting methods. And that's going to return a string because we're using PHP 7. to specify that. And just to prove the sort of TDD workflow, first of all, I'm going to just return hello to prove that the test is going to fail at the point of my control. But when I update that to what's expected, we see that the tests are running. So this really is a great package, and I found over the past few weeks that I'm using a combination of PHP Unit Watcher and manually triggering my test through hardware buttons, depending on the use case. If I'm rapidly trying to prototype a new idea, I kind of want to just control that and run my tests when I want to. But when I'm doing something, perhaps a regression or something of that kind of nature, PHP Unit Watcher is fantastic. OK, so I've described to you about sort of writing our tests as features rather than technical jargon. And whilst Laravel comes with some amazing test tooling out of the box, I think one thing that Behat does really well is the way that it allows us to write our tests as features, rather than having to use PHP Unit to do something that ultimately it may not be designed to do. So using Behat with Laravel was previously quite tricky. I know Jeffrey Way had a package under the Laracasts namespace, which was an extension to kind of allow you to wrap Behat within Laravel. But I'll show you why that's no longer needed. But before doing so, let's just have a look at what Behat allows us to do, the kind of syntax it affords us. So Behat's a BDD framework, which allows us to write tests as human-readable features using Gherkin syntax. So we'd start by writing a feature. So again, we'll use our e-commerce context, our product controller. So we're displaying the latest product, and in order to view the latest products as a customer, I need to visit the home page. So this isn't a BDD talk, so I'll kind of skip what the importance of that part is for now, but do refer to the official documentation to sort of go through why that part's important. But specifically, we then start defining our scenarios. So here we can see that we're trying to display the latest product, and we've written what you may recognize as a very similar test to, I think, one of the slides in tip number 2. So given I have 10 products in the database, when I visit the home page, then I see the 10 products. Really simple example, but we can see that, again, we could hand this file over to any non-technical stakeholder, and they can immediately understand the context. They can contribute to it. If you can convince them to write them for you, even better. So to install Behat, as I'm sure you're familiar, it's going to be a composer package, so we require that using composer require with the dev flag Behat. We then set up Behat by initializing it. So you can either add Behat to your path or just do vendor bin Behat with the init flag to initialize it. That's going to create a features directory in the top level of your project. And all of these features, the one that you see on screen here, is then stored within that directory. Now, when you run Behat for the first time, it's going to create something called a feature context. Now, what a feature context does is it translates each of these steps, so given I have 10 products into the database, into a method. So there will be an equivalent method called I have 10 products in the database. There will be another method for when I visit the home page, and another one for then I see the 10 products. But it does that for you. You don't need to write any of those. Behat is really good at converting this syntax into a method. It will also convert any numeric values into arguments, which is fantastic. So it's a really flexible system. But at this stage, before we can start using all of that magic, Behat needs to know about Laravel for us to be able to leverage some of the great things that Laravel affords us. So to be able to do that, all we do is we open the provided feature context. We just extend test case, which is the abstract class provided out of the box by Laravel. In the constructor, we add a call to parent setup, and that's it. That's all there is to do. You no longer really need to use the Laracasts package to be able to do all of this using Mink drivers and all of that kind of stuff. But the great thing is you now have access to all of Laravel within Behat. So things like the testing traits, using database transactions, migrations, factories, resolving things out of the IOC container. It's all there. And this is an example of one of the methods which is automatically generated by Behat. So I have products in the database, and in my example it was 10, but it's converted that to total. And I've just added the factory to be able to create 10 products or total products from the factory. It's really flexible. I do urge you to check this package out. OK, so tip 9, we've got some great tests. They assert that we're kind of doing the right thing, and our software isn't broken as such. It's complete. It's not going to cause issues on production. But wouldn't it be great if when we're running our tests, we could actually check the quality of our codes? Not that it just does the right thing. So traditionally, we would do this either through pair programming or code review when we submit a pull request, that sort of thing. And they're all great. I'm not suggesting that we should stitch those for a second. But what I'm saying is, how about we add an interstitial step? Before we submit our pull request, we can self-evaluate. So there are a number of static code analyzers or code checkers which exist on the market today which do this for us. It's just a bit of a chore. It's one more thing to do, for us to get up and running with it. So what I've done is I've built a little package which does this for us. So once your tests have been executed, it's going to run behind the scenes PHP mess detector, and it's going to check by default things like cyclometric complexity, unused variables, class length, things of that sort of nature. Now, there are a number of different rules. There are, I think, probably around 50 rules that you can define that your code can be checked against. But before getting into those, let me just quickly recap on how you get this set up. So it's a composer package. So you pull that in using the command above. You then just add a simple test listener, which is on the repository. So you just copy and paste that in, and that's it. So again, we're kind of getting something for free every time we run our tests, which is fantastic. So as I mentioned, there are tons of different rules that you can run this against. Boolean arguments, if-else expressions, and so on and so on. Again, check the docs for a full listing of what you can check your code against. But let's look at one of the more interesting or the scarier-looking metrics, which is a personal favorite of mine, cyclometric complexity. So obligatory Wikipedia definition slide. Cyclometric complexity is defined as a section of source code is the number of linearly independent paths within it. For instance, if the source code contains no control flow statements, conditions, if statements, for instance, the complexity would be 1. If the code had one single condition if statement, there would be 2 paths through the code, one where the if condition evaluates to true, and the other where it evaluates to false. Therefore, the complexity would be 2. What that means is we can see here from my very basic class, we have no if conditions. Your code can only take one route through your method. So you have a complexity rating of 1. Compare this to my complex methods, where the argument can evaluate to either true or false, where we have a rating of 2. OK, so to give you some context, having a rating of 1 to 4 is generally considered good. 5 to 7 is moderately complex. 8 to 10 is high complexity, and 11 plus is considered highly complex. So we've got this method here, and it's just a dynamic accessor of a timestamp attribute. It really shouldn't have all this mess. But if we didn't add this step, our test is going to pass, and it's not going to tell us that we've actually got really poor code driving this implementation. But by installing this package, we can identify that the cyclometric complexity is too high, because we've got a ton of if-else statements, and right at the top, we've got a locally declared but unused variable. So once you've agreed a set of conventions within your team, you can pull this package in, set them up within the configuration file, and your pull requests, or the code review required for pull requests, is immediately significantly faster. OK, my next tip is data providers. So data providers are a fantastic way of running the same single test against multiple arguments. Those arguments may have slightly different expectations, but traditionally, you would write a different test for each of those arguments and expectations. So take the following example. Basic calculator sort of test. So test that it adds 0 plus 0, test that it adds 0 plus 1, 1 plus 1, and so on. Now, again, I get that this isn't a very real-world example, but it really proves, it sort of illustrates the point. The code is repetitive. It's not dry or wet in this case. If we change the instantiation of this underlying class, we'll have to change all of our test methods. It's really difficult to keep track of, and ultimately, it is just a copy and paste job. So what we can do here is we can replace that with a data provider. So a data provider here will return an array of arrays, and each of the items in that array is passed as an argument to the underlying test. So here we've replaced those 4 tests with one, which is it adds 2 numbers. We've got A, B, and total. So here for the first array that's returned, we can see that A would be 0, B would be 0, and total would be 0. So this test is going to run 4 times. If we add more items into our array, it's going to run an additional number of times relevant to that. Our tests are now dry. They require very little management, and ultimately, it's much easier to write a single additional array element than it would be to copy and paste an additional test. OK, so the next tip, this, again, I'm sure you kind of picked up that I'm quite keen on TDD. So it sounds really obvious that I'd say write the tests first. But I came across a tweet, I think it's around 2 or 3 months ago, by Grumpy Programmer. The definitive study on TDD was conducted in 2018, and it concluded that 15 to 30% extra time when using TDD results in 40 to 90% fewer bugs in production. And this blew my mind. As someone that works in a data-driven company, I can now justify using TDD, using data. So the study that Chris refers to was performed by the Empirical Software Engineering Journal, which looked at 4 projects which were undertaken by Microsoft and IBM. And to paraphrase, or to take a subset of the quote, the pre-release defect density of the 4 products measured as defects per 1,000 lines of code decreased between 40 and 90% relative to the projects that did not use TDD. The team's management reported subjectively a 15 to 35% increase in initial development time for the teams using TDD, and this is the most important part, though the teams agreed that this was offset by reduced maintenance costs. So it took 15 to 30% extra time up front for up to 90% fewer production bugs, but the reduction in the time required for ongoing maintenance offset the upfront cost in any case. So you've got a better product with fewer bugs, which actually takes less time. OK, and on to my final tip. And this is a really, it's more of a technical one. How to test almost anything using real-time facades. This is my favorite, actually. Real-time facades was introduced in, I think, Laravel 5.4. But it kind of slipped between the cracks. I've not really seen it being leveraged too much. Let me show you how facades can help with testing. So take the following example. We've got a class with a method called difficult method to test. Within there, we're not using dependency injection. We're just newing up another class, which internally is posting to an API. It's the kind of thing that drives us crazy when we're trying to write tests. The class which is difficult to test, within there, the post to API method is using curl. So again, nothing's being injected. We're just making a direct post request to some API. And it's just really difficult to test without doing a significant amount of refactoring. Something needs to change for us to be able to make assertions on this. And this is where real-time facades come in. I know facades are one of those divisive topics which can cause a bit of division of opinion, but I think the benefits of facades, specifically its ability to mock its underlying class, far outweighs any discussion around them. But again, feel free to slate me on Twitter later for that. So what we can do is, using real-time facades, we can change our import of this class by just prefixing it with the word facades. The class itself stays exactly the same. We change our implementation from instantiating it to the facade style of syntax, and we convert the instance version of that method to a static version. We haven't touched the class itself. It's exactly the same class. Nothing has changed. But now our test, it's actually really easy to write. So we test a difficult methods by adding mocks. So behind the scenes, the facade library will replace that instance method with a mocked version of it using mockery. And we can tell it should receive post to API, want, and return pretended to contact API. So now every time we run this test, it's not going to make a post request to some remote API. It's not going to send an email or do some sort of magic that we really don't want it to do. We're able to mock that with really no significant change in our code other than prefixing the word facades to our import statements. OK, so they were my 12 top tips. Hopefully you learned something new and something interesting and something that you can apply going back to your teams or back to your works tomorrow or whenever you go back. I'm going to be sharing my slides and adding a bit more information. You'll be able to find that at testingtoptips.com. It should be ready by the time you check this, hopefully, if DNS is working as it should. But if not, just bear with it. Alternatively, you can tweet me anytime to claim your sticker, ask me any questions. I'm really, really happy to talk about testing anytime. So thank you again for attending. Thank you for listening. And I invite any questions.
I have a question. What do you do when running your test on a project and it took 10 minutes?
Do you mean for the test itself to execute?
Yes.
Well, there I probably wouldn't put it through PHP Unit Watcher, because that would drive me crazy. I would probably run that test in isolation, just using a filter. But if it's taking 10 minutes, it probably means it's probably doing a bit too much. So it's a good opportunity to break that into smaller tests, or I don't know, I may need to mock some form of dependency. It sounds like it's doing something with an API, perhaps, or
just it touch the database, as you said.
OK, yeah, if it touches the database and it's doing something really expensive, first I try and make a unit equivalent test of that. But then if I need a proper integration test, which I absolutely would, yes, I'd just run those in isolation, just so it doesn't hold up the process. Okay, thank you.
Hi. I just have a question regarding your package. Will it interfere with Grump PHP?
I'm sorry?
It was Grump PHP that runs automatically a lot of tests, including unit tests and mess detector, and then mess detector will run twice or not?
So my package, I've not actually tested it with PHP Unit Watcher. That's a good question. I'll have to look into that. But ultimately, what my package does is you run PHP Unit sort of either manually through the terminal or through your keyboard commands or whatever it may be, and then it will automatically trigger PHP mess detector. I'll have a chat with Freak after the talk to sort of figure out how we can get them working together, though.
Thank you, Amo. Give it a pulse, people.